All right, so the scientific method. Now, in science, and it really doesn't matter which branch of science, so it could be biology, it could be chemistry, it could be physics, or really a host of any other sciences, we accidentally make discoveries. Now, that doesn't happen all the time. Usually what happens is we're going to use a systematic approach to solving problems to figure out, define something as a problem, and then go ahead and solve that. So what we call that systematic approach to solving problems is the scientific method. So let's go ahead and get that written down as a definition. So we have a systematic approach to solving problems. All right, that's going to be our definition of the scientific method. So when we're kind of thinking of it, right, that's what we're thinking of. Now, when we're going through these specific steps, they're going to follow the same every time. And you're going to notice that it's not exactly a linear process, meaning we go from one step and then always go to the second step, always go to the third step, and so on and so forth. But it's more of a cyclical process. So sometimes we're going to jump steps, sometimes we're going to have to go back and redo steps. But the main idea here is that it is a process that we can go over and over and over again in order to solve a problem. So this could be anything from as small as figuring out what's wrong with your bike tire to trying to solve cancer. So this is kind of just the basis for all science, and so we want to kind of take a look at it and figure out exactly what's going on. All right, now, the first thing that we really truly have to figure out with the scientific method is that when we're looking at an experiment, we have to define what we call is a system. Now, so a system is simply just the region of space where we're going to actually do the experiment. So region of space for an experiment. All right, so we don't forget that. Let's just put that over here, and that's what we're going to look at. Now, systems can be really, really, really big. They can be really, really, really small. In chemistry, a system could be the test tube where you're mixing two liquids. For a social experiment, it might be the classroom that we're sitting in during the day. It could be the school, it could be an entire city. So the system is just where the actual experiment is going on, and it kind of, if you put walls around it. So that's what we're really trying to do, is put everything inside a system so that we can control everything that's going on in there, and then we're going to change and make adjustments as we go through that. So we're going to talk about all these different steps one by one and just kind of make it go through that. So first step is simply to observe and collect data. All right, now, observing and collecting data, it's just going to be watching. Now, we can go and get really, really detailed with that, or we can just watch, make general notes. There's two types of data that we're going to specifically look at. The first is qualitative. Qualitative, which what that is that's just going to be using words. So examples of that, we could say the liquid turned blue, or it bubbled. And then the other one that we have is what we call quantitative. So quantitative meaning quantity, and those are going to be using specific measurements. So that might be we're going to weigh out 10 grams of something or put in 45 milliliters, whatever it is. So those are kind of the two ways that we're going to observe and collect data, and that's always going to be the first step of our scientific method, okay, the process that we're going through that. So we'll just kind of put a box around that one. That's going to be the first step. Let's actually make those a bit smaller, out of the way. Okay, so there's the first step. Now, next step that we're looking at is going to be to formulate a hypothesis. So, formulate hypothesis. And what a hypothesis is it's just a testable statement. So let's put that there. Testable statement. Okay? Or an idea. And that could be something really, really simple, like if I poke a hole in this tire, all of the air is going to come out. Do you see how we can kind of test that? We look at the tire before, we poke a hole in it, we wait a little while, and the air came out or the air didn't come out. So we have a testable statement. All right, that's always going to be the second step as well. And after this is where we kind of start to get tricky a little bit, but same way, we're kind of going to go in a general order. So there we go. All right, next one is actually going to be testing. And this is where we're going to be in the lab, or with our example of our bike tire, we poke a hole into it and we watch and see what happens. We could actually measure how much air comes out if we wanted to, or we could just use, and that would be an example of quantitative data, right? We're measuring a specific amount, or just qualitative. It is now flat, whatever it is. So testing, this is what we are going to do an experiment with. And this is really what I consider the fun parts of science, but they're all necessary. So we just kind of work with what we have. All right, so we'll put that down there. Let's put a box around it. That way we know we're good to go. All right. Now, from our actual testing, this is where we're going to start to create theories or models, or basically explanations for what our tests proved, okay, or at least alluded to. Okay, so a theory, let's just define that real fast. And what a theory is it's just a general explanation for the results. And that's what we're going to create. Oftentimes we're going to create a model. Let's move that up. I'm going to add to it real fast. Okay, so we might create a model, which all that a model is it's just a physical object to show results. Let's put a box around all that. There we go. And we're going to add it to our list. Okay, so we can kind of see how we're starting to go through and create this process. We're going to look at something, collect some data on it, whether it might just be observations about what it is or really specific measurements that go with it. And then we're going to start to take guesses as to what would happen. Okay? And they have to be testable. That's a really important concept. From there, we're actually going to do those experiments. And this is where we need to be creative and look for ways to actually problem solve within science. Once we're done testing, we're going to create a theory. And that's just, again, that explanation for what we're actually looking for. Now, here's where we start to kind of deviate with a lot of things. If our idea, okay, so our original idea, right here, if that wasn't true, well, then what we have to do is we have to go back and create a new idea. Okay, so far, right, all of these have kind of been in an order, but if something's going not quite aligning with our hypothesis, right, remember this is where we created our idea for what we're doing. If it doesn't work with that, we have to go and redo. Okay, now we're going to make this circle lots and lots and lots and lots of times. So we're going to observe, create an idea, test it, come up with an explanation, and we might have to go back, formulate a new hypothesis, create a new idea, go through that process, and you can see how this is a circle. Now, eventually, we might get to the point where we want to publish our data, okay, or publish our results. And this is what you see when you look in scientific journals. So this is all that it is just a communicating what you've learned. Which, this is where people win the Nobel Prize for chemistry and just other things like that. So this is when, people say that they're a published author or write textbooks or all that other kind of stuff. They're communicating what they've learned, what they've found, and, that's kind of the last step to this. So we got all these different steps that start with observing something, creating our testable idea, actually testing it, creating some sort of explanation for it, which we call a theory, maybe making a physical model to show our results, and then telling everyone else about it. So in a nutshell, that's the scientific method, and that's what we're going to use when we try to do chemistry this year. All right, guys.